So this whole section is about solving equations. We are going to use the properties that we have been talking about to solve these equations. All of these equations are going to either be in exponential form or logarithmic form, and we're going to use properties to basically get them into something that is solvable. The first thing that can happen is you can have two bases that may not be the same, but you can see that they are related by a common base. So if I look at these bases, on the left-hand side, my base is 27, and on the right-hand side, my base is 1 over 9. 27 and 9 have a common base of 3. I can rewrite 27 to be 3 cubed. Everybody agree with that? That is 27. So 3 cubed to the x. I can rewrite 1/9 to be 3 to the negative 2. Does everybody agree with that, right? Remember, if it's in the denominator, that's just a negative exponent. And that is to the x plus 5. So I can rewrite these to be common bases, all right? Now I'm going to use my properties of exponents. I'm going to say, well, if I have a power to a power, I just multiply. So this is 3 to the 3x. And this, I'm going to distribute this guy. So this is going to be 3 to the negative 2x minus 10. All right? Now I have base to a power equals the same base to a power, which by my property says those powers must be equal. And so now I'm going to take those powers and I'm going to set them equal to each other. 3x then must equal negative 2x minus 10. And now I have a rather simple equation to solve. Move my x's over. I get 5x equals negative 10. And then divide both sides by 5. X equals negative 2. And that's my answer. Now I can test this. How do I check it? Well, I can check it by plugging it back in, right? Plug it back in. You'll see that 27 to the negative 2 is going to equal 1/9 to the negative 2 plus 5. And you're going to get the same answer there for both of those, all right? So figuring out that they have a common base and just rewriting them to their common base is one way to solve. Because once your bases are equal, your exponents have to be equal by that property. So let's try one. You will then have times when you cannot rewrite them to like bases. You cannot rewrite 10 and 4 to a like base. They're not of the same base. So the easiest thing to do, though, when it's 10, or when it's like B here where it's E, is to multiply both sides by the log that cancels it out. So I have 10 to the x plus 1 equals 4. I am going to take the log of both sides. For the 10, I'm going to use common log. So I'm going to say the common log of 10 to the x plus 1 equals the common log of 4. Take the log of both sides. These logs cancel each other out. I just have x plus 1 equals log of 4. Subtract 1. So x is going to equal log 4 minus 1, which is a number. When you plug that in and round it to the nearest 10,000ths, you get negative 0.3979. All right? When you have something like b, I obviously don't want to use common log here. I mean, you could, but that's not the easiest way to do it. If I have something like this, I'm going to use natural log. Natural log of e to the negative 5x equals natural log of 17. My natural logs cancel each other out. Negative 5x equals natural log of 17. Divide both sides by negative 5. When you put that into your calculator, you get approximately negative 0.5666 decimal approximation. I really think the easiest way is to either use common log or natural log all the time. You can use the log of the base that you have. So like, for example, my base in this a is base 5. So I can actually do log base 5 of both sides, and it will cancel out the left-hand side. And on the right-hand side, I'll just do change of base. And so I'm going to show you that way. Or you can do common log or natural log and expand. And it works out to be exactly the same problem. So bases cancel out bases. So I could, if I wanted to, do a base 5 here. What will happen on the left-hand side is this will cancel and I'll be left with x. And over here, I need to do change of base. Log of 7 divided by log of 5. That's one way to do it. Easy enough, right? Or you can do common or natural log of both sides. So if I do common log of 5 to the x equals common log of 7, I can expand, right? So that x is my exponent. It goes in front. I have x log of 5 equals log of 7. To solve for x, I divide by log of 5. X equals log of 7 over log of 5. Those are both obviously the same thing. When you round to the nearest, you're going to get approximately 1.209. Either way, you get the same exact answer, okay? So bases cancel out bases, change of base, whatever you need to do. Now, the next one, you're not going to want to do that first method. Why? If you look at this one, the left-hand side has a base 3 and the right-hand side has a base 5. You cannot take the log of different bases. It's an equation. Whatever you do to one side, you must do the same thing to the other. So I cannot do log base 3 of the right-hand side, or the left-hand side rather, and log base 5 of the right-hand side. I have to do the same log, right? So that doesn't really help me if I do that. So for something like this, you do want to use either common or natural log. And again, it does not matter which one you do. All right, so in the book, they used natural log, which is fine. So I would do the natural log of this equals the natural log of this side. And then I'm going to expand both sides. I'm going to pull that 2x minus 1 into the front. And I will have natural log of 3. And then I'm going to pull that x into the front. And I will have natural log of 5. All right? Now, for this one, they actually distribute it through because we have a little issue here going on. And so we really need to get all of our variables to one side and all of our numbers to the other. And my variable is in a group. So we're going to distribute here. We're going to go through this process and distribute. So we have 2x natural log of 3 minus the natural log of 3 equals x natural log of 5. All right. So then I want to get all of my variables on one side and all of my non-variables on the other. And probably just because of the negatives, they moved this guy over here and that guy over there. So we have 2x ln of 3 minus x ln of 5 equals ln of 3. All right. And now, hopefully you can see I can factor this guy out. There's an x for both of them, right? And so I can take an x out. And I have 2 ln of 3 minus ln of 5 equals ln of 3. And then you can just divide, all right? So divide both sides by that group. It doesn't matter how you do it. You could condense that group if you wanted to. They condense part of it and not the other. I don't know. It doesn't matter. You can make that, 9 times 5, ln of 40, or 9 divided by 5, ln of 9 over 5, and do it all as one. Or you could leave it like this. Either way, you're going to be dividing this ln of 3 over this whole group here. It just depends on how you like to put it into your calculator. They wrote it as ln of 9 minus ln of 5. They went ahead and put that 2 as the exponent, probably so they wouldn't have as many calculator strokes. But either way, you're going to get the same thing. And they rounded again to 3 decimal places. Why they chose to do that here, I don't know. All right. So for this one, it doesn't feel like you're going to factor here. But it does look like a trinomial, hopefully, right? So if you think about this as a trinomial, as long as you have squared 1 and a number, you can either factor or solve by quadratic. But in this case, we're solving by factoring. So you can think of this as e to the x squared, right? Everybody agree? If it's to the 2x, it's to the x squared, right? Power to a power. Minus 4 e to the x minus 5. Now, in this case, this is easily factorable. I need factors of -5 that add up to -4. What are those? -5 and +1. So I am going to say, think of this as your variable, right? X squared minus 4x minus 5 would be very easy to factor, right? So I have, instead of x squared, I'm going to write e to the x minus 5, e to the x plus 1. What do I do with my factors after I factor it? I set them equal to 0. E to the x minus 5 equals 0. E to the x plus 1 equals 0. All right. Add 5 over, I get e to the x equals 5. How do I get rid of an e? You're always going to use natural log here, right? So ln of both sides, you're going to see that x equals the natural log of 5, which is approximately 1.6094. What happens on this side over here? I get e to the x equals -1. If I take the natural log of both sides here, I get x equals the natural log of -1. What's the problem with the natural log of -1?
It's not imaginary.
Yeah, it's imaginary. We cannot do a natural, there is no real number that can take natural number, 2.17, whatever he is, and make him a negative number. We can't do that, okay? We can make him a smaller number, a decimal, but we can't make him a negative number, okay? So this one does not exist, so the only solution here is going to be this guy. All right, let's try one. This one's easy, honestly. Here's the thing with this one. You have the same exact log on both sides, right? The only problem is that 2. So anytime you have something like this, your thought should be condense, right? To get rid of that 2, we are going to condense it. We're going to put it into the exponent place. So I'm going to say I have the natural log of x squared equals the natural log of 9. Well, if I have the same base of something equals the same base of something, the insides have to be equal. So x squared equals 9. What does x equal? Technically, it's positive and negative 3 if I were just solving for x. What's the problem with this? If I plug this back in, I'm going to say the natural log of negative 3. Negative 3 will cause a problem, right? So it's going to only be 3 here. 3 is my solution, right? Because I cannot have a negative. My domain, it's outside of my domain of positive numbers. Okay? Good? All right, let's look at example 6. All right. For this one, again, condensing is something you probably want to do here. The problem here is my logs are on different sides. So I can't really condense that right-hand side because I have this crazy number there, right? That's not in a log. You can't condense a number that's added or subtracted. He's not part of the log. So when you have something like this, you have the same bases, base 5, we're good to go. Move all of your logs to one side, all of your numbers to the other, and then condense the side that has your multiple logs. Condense them into one log, right? And so I am going to move this over, and I'm going to say log base 5 of x plus log base 5 of 2x minus 3 equals that 1. And now I'm going to condense them, right? How do I condense something that's being added? Well, I multiply them. So this is log base 5 of x times 2x minus 3 equals 1. And you can simplify that, guys. So we have, the log base 5 of 2x squared minus 3x. Now, remember, bases cancel out bases, right? What's the base of this log? 5. So I'm going to use a base of an exponent. I'm going to have 5 as my exponential base here on both sides. On the left-hand side, it cancels out. I have just the 2x squared minus 3x. On the right-hand side, I have 5 to the first power. What is 5 to the first power? Just 5. Had that been a 3, I would have been 5 cubed. 125, okay? So whatever it is, you literally need to take it to that power. Sometimes people forget to do that other side with the number. So we have 5 to the first power equals 5. I have a quadratic. What is my go-to method of solving a quadratic? Probably factoring, right? So move that 5 over. 2x squared minus 3x minus 5 equals 0. If you don't know to pair them up, right, you're going to pair them up. The only options I have in the beginning are the 2x and the x, right? I need that to be a negative 3 on the inside. My only options for 5 are 1 and 5, right? 1 has to be plus and 1 has to be minus, all right? So I naturally want to pair up that 5 with the 1 because 5 minus 2 is 3. And I don't want to multiply that 5 to multiply by the 2. So if I put it here, I'm going to get a 5x and I'm going to get a 2x, right? 5x and 2x subtracted give me 3. Specifically a negative 3. So I want this guy to be negative and that guy to be positive. Or let's say you don't remember how to do that. You can do this. Multiply across factors of 10 that subtract to give you 3, right? That's going to be what? Negative 5, positive 2. You can rewrite it. 2x squared minus 5x plus 2x minus 5 equals 0. Factor by grouping. Take out an x, 2x minus 5. Take out a 1, 2x minus 5, and you're going to see that's your factors that you're going to get. Either way, we're good to go, right? Both the ways you can factor. Set them equal to 0. I'm going to get x equals 5 halves or x equals -1. Does anything cause a problem if I were to plug it back in? Yeah, the 5/2 is not going to cause a problem, but -1 causes a problem right here. It actually causes a problem on the other side too, because you get -5 over there, right? So this guy doesn't work. He is an extraneous solution. That guy works. Does it take? So doubling an investment is what we're going to do here. How long does it take for $4,000 invested at 6% annual interest to grow to $8,000 if interest is compounded monthly? So they have told us everything except how long. So we're going to fill in everything except how long and solve for that, right? So I am growing my money to be $8,000. That's going to be here. My initial, that's going to be my principal. That's what I invested. My formula is what I have in my account is what I invested, 1 plus my rate over the number of times times t, right? That's our formula. So 1 plus my rate. So my rate is 6%. I write that in decimal form. Compounded monthly means it's compounded how many times a year? 12. And then N and then T is what we don't know. Now here's the thing. Divide that 4,000 out first. First of all, they told you at the beginning you were doubling your interest. When they tell you you're doubling your principal, when they tell you doubling, then when you divide that out, you're going to end up with 2. If they said triple it, then when you divided out your principal into the other guy, it's going to be 3. So even if they don't give you the numbers, if they say, how long does it take to triple it? You're just going to put a 3 there because that's what would happen if you divided. So when we divide out that 4,000, get rid of him, it's just going to be a 2 here. This is actually a number, all right? It's an actual number. So what is that actual number when I say 1 plus 0.06 divided by 12? What is that number I get?
1.005.
There we go, to the 12t. Now I just have an equation to get that out of the exponent. Take the log of both sides. Take the natural log of both sides. It doesn't matter which one you use. Log of this side, log of that side, right? So I have the log of 2 over here, and now I can expand this guy. Equals 12t times the log of 1.005. I am solving for t. How do I solve for t here? Just divide everything except that t, right? So we're going to divide both sides by this 12 log of 1.005. It will cancel all these goodies out. That means t is going to equal log of 2 divided by 12 log of 1.005. You get approximately, and they rounded to 1 decimal place, 11.6 years, right? If they said to the nearest year, you'd say 12 years. If they said years and months, you would say, 6/10 of 12 months, right? So